Okay, my this is visible like here, Bhavya?
हाँ सर.
Yeah, okay. So shall we understand the concepts of that workstations and minimum output and that first? Okay, so we say, for example, why it is not working? Bhavya, shall we start with the workstation problem?
हाँ सर.
Yeah, okay. So workstation problem is like, I will give you an example. We say that a work is has got five activities A, B, C, D, and E. This, for example, it takes 60 seconds. This takes 30 seconds. This also takes 30 seconds. This takes 20 seconds, and this takes around 30 seconds. So the first thing what was covered in the lecture is known as the minimum cycle time, and another is the max cycle time. And here only I will say, for example, in a day there is a shift of 8 hours, single shift. So first thing comes, the minimum cycle time is the time of the activity which consumes the maximum time. So in this case, this will be 60 seconds and it is coming from activity A. The maximum cycle time is like that if we do these activities sequentially, then what is the total time? So it will be 90 plus 30, 120, 140 and 170 seconds. This is coming from all A plus B plus C plus D plus E. Now what is the, from here only, what is the maximum output possible? So maximum output possible will be from the minimum cycle time. So if we say this will be total time available, and this session is basically to learn from each other. So anywhere I'm going wrong, please interject so that we can discuss that. And this will be, so this will become like 170 over 60. So this is 2.83.
Sir, shouldn't
Oh,
it be 8 into 60?
sorry. That's why I had said. Yeah.
8 into 60 divided by 60.
Yeah. Yeah. So that I made that mistake deliberately so that somebody catches. Okay, and similar question is given in one of the quiz also. So time will be now time we have to take in seconds. So this will become 8 into 60 into 60. 60 cancels. 8 6 are 48. So maximum output which is possible is 480 units per day. Okay. What is the minimum output possible if we do sequentially? So that will be 8 into 60 divided by 170. So this figure will come. So this is the minimum output which is possible. Now here only, if they give us a question, for example, that there is an output of, for example, maximum possible is 480, but presently this in some industry with these settings and we are achieving only output of 200 and we have to find the efficiency. How will we do that? So what we can say that maximum should be 480. So if it is producing 480, then efficiency should be 100%. But now it is producing 200, so we have to find the efficiency. So for that, we have to find the percentage of idle time. Now here there are 5 activities, and when we say that we will achieve this maximum output, it means we will be working on 5 workstations. 1, 2, 3, 4, and 5. And we are having output of 200. So to find the efficiency, we have to find percentage idle time, because efficiency is 100 minus percentage idle time. For percentage idle time, we have to find the cycle time. Presently, what is the cycle time? So cycle time is equal to what is the maximum available time and what is the output, present output. Bhavya, can you calculate again this, please, fast again? So this will become 18 into 848 into 3 to 3 4 12 144. Is this clear till now? Anybody, any doubt? Vineet, are we there in the call? Hello, Bhavya? Hello.
Yeah, you are audible.
Okay, thank you so much. So till now things are clear about this.
Yes, yes, clear. Yeah.
Okay, so now from here we have to find the percentage idle time. So we have found that for this output 200, cycle time we have found 144 for output 200. Now for this we find percentage idle time. Percentage idle time will become that all these workstations, these 5 workstations which are there, how much time we are not utilizing. So first workstation was 60, so here this much of time we are not utilizing. Second was 30, third was 30, fourth was 20, if I'm not wrong, I can go back, and last was also 30. And how many number of workstations are there? So workstations are 5. What is the cycle time? 144 into 100. So from here, you can do another thing also. You can write it as 144 into number of workstations is 5 minus sum of all activities, time of all activities, divided by 5 into 144 into 100. This will become 144 into 5 minus 170. This can, so here, for example, some figure will come. Shall I calculate, or somebody can calculate this fast?
Yeah, let me do. Yeah.
Yeah.
Point 90. Wait a minute. Wait a minute. $76.38.
Okay. So now your efficiency of this present is 23.62. So this similar question has been asked in all the quizzes. So this is how we have to approach this. Afnan, am I correct? Okay? Can you give some input in this? Is still there?
Yeah, I think it's okay only. Yeah.
Yeah. Okay. So with this concept, okay, now the second concept comes where we have to, we have got the preconditions. Like we had okay, these activities, for example, A, B, C, D, and E. 60, 30, 30, 20, and 30. Now for this, okay, there might be a question that we have to do activities like B, C, D, E. And for A, there is no precondition, time is 60. For B, for example, there is a time 30, but precondition is A. For C, 30, and for this is A. For D is 20, for this is BC, and for E is 30 for D. Now, next question is, what is the theoretical minimum number of workstations? Workstations. So this is nothing but this is max cycle time divided by min cycle time, and it has to be in integers. So max cycle time was 170. This was 60. So this will come around 2.60, 12, 5, 6, 48 something, and we increase it to the next integer is 3. So this is the question again from the quizzes to find the theoretical number of workstations. Now fourth part is how to schedule them. So for that I will change the color. Now, for example, if we have found that total theoretical is 3, can we do it in 3 with these preconditions? So we make the workstations now is as per the 3. So time for every workstations will remain 30. So we can give A here, we can give B and C here. We are consuming 60, we are consuming 60. And now here we can give D and E. First we do D in 20 and then we do 30 and we are consuming 50. So this can be achieved with on the 3 workstations. However, depending on the preconditions, we have to check, and I'll give you how do I do it. What do I do it? I make a time this. This is the time. This is the max time. And you keep on writing the activities. For example, here is A, B, C, D, E, F, G, H from the this. And here we have got like in Agile, we follow the that Agile sprints. So here also it is a sprint of the this 60, 60, 60. So you keep on filling. For example, A, there is no precondition. I can do it that in 60 seconds. So this is possible. B takes 30 seconds. It can be done after A only. So it will come here to 30. C precondition is A. After this is 30. For D, precondition was BC, time was 20 seconds. So here it comes here. So it is possible. For E, it takes 30 seconds. Precondition is D. So it takes 30. So this is possible. So in the question, if the questions options they come, for example, many questions theoretical we have found 3, but they have said okay, they have given 4. So various combinations will be there. So please check those preconditions are matching, number 1. Number 2, this time which is there, if for example, if they have given 4 workstations, then what is the time? So that time should not exceed that time which is there. And one by one, you can check whether this option is possible or not. Shall we do one question about this again? Shall we check
Yes,
one?
yes.
Yeah.
Yeah.
So, okay. Okay, so this is one other question, similar question. So to understand the concepts, we had taken simple ones, and this we can cover in the last. In the course. And in this question, they have given us 10 workstations. They have given initially 200 cakes and shift of 8 hours. 10, 200, 8 hours. So number of workstations is 10. Present output is 200. Time is 8 hours. And in the question, they have asked maximum possible output, uh, theoretical number of workstations, current efficiency, what is the layout which is possible, and what is the efficiency of the best possible layout. So that we can do one by one. So before that we find okay, what we have done. So we find minimum cycle time. Min cycle time in this question is equal to 60. Max cycle time is equal to sum of this 30, 60, 90, 130, 150, 155, 160, 160, 175, 180, 185. So straight away from here, we can calculate min number of workstations. And this is a theoretical figure. So this will become 185 over 60. Straight away, this comes 4. So this we have solved. And we come to what is the present efficiency. So present efficiency, what do we do? First we find cycle time. What is the present cycle time? So present cycle time is total time available divided by output. So this is 8 hours into 60 into 60. Now remember this is in seconds. That's why we are taking in seconds. Output is 200. So this is 144. So now percentage idle time will become 144 into 10 minus sum of this is 185. Number of workstations is 10 into 144 into 100. 1 minus 185. Can somebody give me this calculation?
Yeah, I'll see.
Yeah.
$87.15.
87.15. So therefore efficiency will become 100 minus 87.15. This will become 12.5. So this is the efficiency.
What is the maximum possible output?
Maximum out. Yeah. Okay. So maximum possible output is that if you are taking a cycle time of this 60, maximum possible output possible theoretically is equal to total time available, and you are using this 60 minimum cycle time. So this will become 8 into 60 divided by 60. So 480 units per day is your capacity.
Okay.
Okay.
Got it.
Yeah. Now we can go to the third part.
So always we should take minimum cycle time, right?
Yes,
To
for
calculate maximum.
yes, for maximum output, always minimum cycle time.
Okay.
For
Okay.
minimum output, take total time.
Oh, okay.
Okay.
Only total time is enough.
Yeah, total time. This 185.
Okay. Okay.
Because in the minimum we are considering that we are making sequentially, that one product we will do here, then we will come here, we will come here. So we take 185 seconds to prepare, make one product.
Okay. Okay. Okay.
Okay.
Got it.
Whereas in the workstations we go one by one. We come here, we do that. Okay. Okay.
Minimum output will be like total time available divided by maximum cycle time.
Yeah. Yes. Yes. Yes.
Got it. Got it.
Okay. Now, what was the third part of the question? I'll just check it.
Now workstation. We need
Workstations.
layout. Yeah.
So workstations we had done the calculation. So workstations are how many? Theoretical?
Four.
4.
Yeah.
So if there are 10, okay, we can reduce by 6. Okay.
Yes.
We
Yes.
can
Yes.
reduce by 6, okay. So that's there. Now we come to what is the current efficiency we have done. Now, which among the following layout is the best possible layout? So this we'll check. Okay. Shall I rub it again?
Uh,
This one.
if we rub this, then for tomorrow's reference, it won't be there, right?
Okay, okay, okay. So we'll come one by one here.
Yeah.
Okay. So for this, like I mentioned, sorry.
It can be third or fourth only, right? Because only four workstation.
So we will learn the concept, okay, basically how it is done. Okay. So first, what we have to do, see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are 5 workstations. 1, 2, 3, 4, 5. 5 workstations. 3, 4. Here are 4 workstations. 1, 2, 3, 4 workstations. We found that minimum workstation is 4 and all are greater than 4. So all 4 are possible as per this condition. Okay. If here it would have been 3, then straight away we know that it is not we can strike off that possibility. Now what we do, we make this. So we know that total time is 185 and
Okay, then five is also possible, right? As you come to say.
yes.
Because it is theoretically we are predicting it can be four.
Yes. But okay, we can have more also. Nobody stops us.
Okay, but it should not be less than theoretical value. Okay.
Yeah. So what do? We make a chart like this and we start making the timings. So A is 20 and there is no condition with that. So A can be done, for example, in 20 seconds. And here we make 20, 40, 60, 80, 100, 120, 140, 160 and 150 and 200. So this is no precondition. A can be achieved. A is 20, B is 10. No condition with B. So B can be done. A and B can be done in parallel. C is 60. And
I
for
guess you
this,
can paste that, take a screenshot and paste it in right side, right? It will be
yeah,
correct.
yeah, you're right.
Why 20-second interval?
Just for my cap and just to make this graph, okay, nothing like that.
Okay, okay.
Okay, but we know from here that minimum cycle time it is 60.
Yes.
Okay, so ideally I should have something like 60.
Yes,
This
that's what my doubt was. Yeah.
this was 1, this is 2, this is 3, and this is 4. So I'm just covering again that see in the paper we will have our quick hints, okay, how to solve it. Like first hit, okay, we have found from here. But I'm just covering the concept, okay, that how we can do, more elaborately. So now for A, B, C, there are no conditions. Now D, there is a condition that it can be done after A and B only. It means A is finishing here. The D can start from here only, and it will go up to, this was 20, this was 10, it takes 40, so it will go up to 60. From D, now there is an E. For E, there is a condition that C and D should be completed. C is completed in 60, so this is 60. Here also this is 60. Baking can start after that only. So from here, E can start from here only for 20 seconds. Now F will take 5 seconds, for it is E. So F will take 5 seconds from here, and for this is precondition is this. For G, E and F, both are preconditions, and it will take 5, again 5. So it will come here. H is G, it will take 15. So here it will take 15. And J is packing after I, it will take, I think somewhere I have missed something. A is correct, B is correct, C is correct, D, E, F, G, H I have made. Okay, I had forgotten. I is 5, H, and J is 5 here. So now take you workstations and find out which one can be done one by one, and any violations in that. A, B can be done together, no problem.
Yeah, no problem.
Okay. C, 60 can be done. We are taking 5 workstations are there, and the time is minimum cycle time, which is 60.
Okay.
So here we have taken 20 and 10, and they can be done on one workstation we do. So we are occupying 30 time. My wastage is 30. Second is C. I occupy 60. It is possible. I occupy 60. Wastage is 0. DE, 40 and 20, they can be done in 20 seconds. So there is no problem. DE can be done 60 second, nil wastage, 60 occupy. A, B, C, D. D and E. F, G, H, I. F, G, H, I. Time is 45 seconds. It can be done. Wastage is 15 seconds. Total time 45. And then we can do last activity in 5. Wastage is 55, and it can be done.
It's
So this
actually 30 seconds, not 45, I guess. FGHI.
FGHA. FGHA. F5. F is 5, G is 5, H 15, 5, 20. Yeah. 5, 5, 10, 25, and 5, 30. FGHI.
Yeah, it should be corrected.
10, 25, 30. 30. So this is possible. There is no violation of precondition. So this can be achieved.
Yes, it can be
Okay.
correct.
Now we come to this option A to C. So straight away there is a violation, because for no A, C, there is no problem. It can be done because here preconditions are not there. So we can done A. We can done C. There is no problem. B, E, F. B, E, F is 10, 20, 5. But for E, there is a precondition of D. So there is a violation here.
Yes, there is a
Okay.
violation.
Okay. So
Yes.
this cannot be achieved. Now we come to third. A, B, same situation. C, Same situation already we have checked. D, no problem, 40 seconds. Now check E, F, G, H, I, J. So here is 60, 60, 60, 60, 60. E, F, G, H, I, J, 25, 30, 45, 50, 55. And there is no violation of any precondition. So this also can be achieved.
Yes, correct. Yeah.
Okay, and we have found that in 4 workstations we can achieve that. Now here, if we see A, B, C, D, G, there is a violation because for the G, there is a precondition. Okay, so this cannot be achieved. Okay, Bhavya?
Awesome.
Okay, now the question will be asked that what is the efficiency of the best layout? Now see what will be the best layout. We have found 2 options from here. One option is this one. Another option is this. But which is the best layout? Which should give me the best efficiency? Which has got less number of workstations? That is the best efficiency?
Yes, yes.
Okay.
Correct. Third option.
Yeah. So now again, what do I do for the best efficiency? What I will find out? I'll find out. So for the best efficiency for 4 workstations, my cycle time is 60. Now I will find that at every workstation how much time I am wasting. So here I am wasting how much? 30 seconds. AB first. Second is 60 minus 60. I am not wasting anything. I am occupying all C. At D, I am wasting 60 minus 40. At E, F, G, H, I, J, which came 55, so I am wasting 60 minus 55. So this is my wastage. Divided by number of workstations into cycle time, this is the percentage idle time into 100. So this will become 30 plus 20 plus 5, 55, 4 into 60 into 100. Can somebody give me this, please? Okay. 5 plus 1, 5, 12, 425, 125. Suraj, can you give me this figure here? How much it is coming?
Around 23, 22.9, I guess.
22.9. Okay. So then our efficiency becomes 100 minus 22.9. So this will become 77.5. Okay. Any question till now here? Okay. So what we have covered the min cycle time, we have covered max cycle time, we have covered max output possible, we have covered minimum output possible, then we have covered cycle time, we have covered the formula for efficiency, we have covered how to find the percentage idle time. Okay, and from there we had taken this example. We cleared some concepts and then how the layouts are possible, and then we covered this. So anyone, any doubt or any clarification or any add-on? Afnan, you want to add on something here? Bhabe, do you want to add on anything?
No, sir, all good.
Okay. So this is one calculation part which is commonly coming in quiz. So that has been covered. So points to take from here. Now we go to second part that activities which are there because I will just open this. This is the quiz one questions. Efficiency, workstations, best layout we have covered, layout which is possible, and in fact, okay, we can if we can find the best layout also. Now, second question is this question which has come for the calculation. This is from week 4. Where is the supplier selection problem, and these are the suppliers, and these are the attributes. So, how many item sets are there with cardinality or number of elements equal to 3? How many item sets have support vector value greater than or equal to zero point 0.3? What is the probability of observing price premium? This, so I will cover, take this and we'll cover one by one. So in the lecture, if you remember, a very important thing was covered was K. Here, number of attributes are, for example, 1, 2, 3, 4, 5, 6. It is like making the dummies which we did in machine learning practice. So for every rank, okay, we will make dummies, and the ranks which are available here are 3. So we will have dummy variables 18. 6 into 3 is equal to 18. And how do we do that? Here only, unfortunately, this is, I will cover. Right. Okay. So how do we do that? This supplied network which is there, we change it to SN1, SN2, SN3. This is ES1, ES2, ES3. This we have done in our machine learning practice. UR3, PP1, PP2, PP3, C1, C2, C3, M1, M2, M3. So this 3 which is there, this can be written as 0, 0, 1. 2 I can write as 0, 1, 0. 1 I can write as 1, 0, 0. This I can write as 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0. Similarly, this 1 I can write as 1, 0, 0, 0, 1, 0.
Is it we should do for all the things?
Yes, yes, it will take some time because it will help.
Oh,
It will help us in all the questions. All,
okay, okay, okay.
so this is 1, 0, 0. Oh, sorry, 3. This is slightly time consuming, but it will help us in all the questions to understand.
Mm-hmm. Sure, sure.
Otherwise, in the lecture, they have covered the Python code, how to do that. But this is for the understanding basically.
Yeah, got it, got it. Yes.
Now first concept comes again, the number of item sets. See, number of item sets are like, they can start from 1. For example, there is an item set only 1 SN1, SN2, SN3, all that. Or they can go SN1, ES1, SN1, QR1. So various combinations which are there to see the associations. Basically, we are interested in finding that, for example, if management is 1, then what is the chance that its employee skills are very good. So we are trying to find association between the attributes. Now further, management is graded in 3, 1, 2, and 3. So we have made dummy variables, management 1, management 2, management 3. And as per that, okay, we will try to find the associations. So the first question here was, how many item sets are there with cardinality or number of elements equal to 3? Cardinality 3 means that there are 3 elements here, 1, 2 association with third. So for that, straight away formula is there, 18C3, because there are total 18 and we need, okay, 3 elements. So this is 18C, this will become 18 into 70. So this is the answer. So here we have understood, okay, this concept, number of elements, cardinality.
Yes, got it. Yeah.
Okay. The second question is, how many item sets have support value greater than or equal to 0.3? So now here, please pay attention. Now first find the total number of items is 10. Now try to find that how many times this is occurring. So sum this, SN1. So this is 2. This is 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5. 1, 3. 1, 2, 3. 2, 3, 4. 2, 3, 4.
I guess C2 is 4.
3. Which one?
C2.
1, 2, 3. No, 3.
1, 2, 3. No, 4 only. It's coming. C2. Customers. C2.
C2, 1, 1, 2, and 3. This is slightly snake position.
I'll say first row has, right? Customers C2 first row, third row.
C1
Sixth
check.
row.
C1 is C1. देखो 1, 2,
Yeah, C1
3.
is fine.
1, 2, and 3. See, last ninth row has also got 1. First row has got 1, third,
Yeah.
and ninth.
Yeah.
First,
In between.
first,
In between.
third.
1, 2, 3, 4, 5.
Okay.
Sixth row.
Okay. Yeah, you're right. You're right. My bad.
C3 is perfect. Yeah.
This is perfect.
Yeah,
This is
perfect.
3. Now they have asked that how many items that they have got more than items that have support value greater than or equal to 0.3. Now here, any item which has got less than, this is 0.2, 2 divided by 10. So anywhere in data mining course we had learned that
Why 10? Like, I don't know.
this support of SN1, for example, is
Okay.
equal to number of times SN1 divided by total times. So this is 2 by 10 is equal to 0.2.
Okay, rows are 10. Okay.
Okay. Now, if its support is 0.2, then in future, wherever you associate this variable, it will not exceed 0.2. So straight away, we can cut this.
Okay.
Okay.
Correct. Yeah. 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 Correct. Now for 3.3,
Okay.
0.5.
Okay. Okay.
Others will come, right?
Now here in this question, there is only slight problem. All of them now rest all. So now how many variables are left? Okay, 18
18
minus
minus 4.
4. So
14.
14 item sets, so straight away we can say that they have got support of more than 0.3.
Hmm. Got it.
And now what do we do? Now we make various combinations of that 14 and we start checking now which have got, okay, for example, now I know SN1 I have got stuck. Now I will check SN2, SN3. Now I will take the combinations of 2, 2. SN2 employee 1, SN2 employee this. So I'll give you an example only employee 2 by taking SN2 and SN3. So here we check SN2 support to SN3. So check how many times SN2 and employee, for example, SN3. Okay, we are checking with SN3. This is a variable, so they cannot become a SN2 and SN3 will not have more than 0.3 because either can be 0 or 1. So we check with SN2 and E1. So check how many times SN2 and E1 both are 1, 1. Can we check that? Here it is not there, it is not there, 1 and 2. So SN2 E2 support is 2 by 10. So this is again 0.2. Is it clear?
Slightly.
Yeah. So in this question, only I've got a confusion, and that's why I said, okay, this is not a correctly framed question. They're asking how many item sets have support value greater than or equal to zero point 0.3. Here they should have written the cardinality.
Okay.
For
Okay.
example, cardinality is 1.
Mm-hmm.
Okay. Then if it is a cardinality is 1, then
Then
straight
14
away,
will be the answer.
yes, then 14 is the answer. Otherwise, what will keep on happening? That we have to explore all the item sets.
When it is not
That takes
specified, we
time.
have to create the largest item set and use that for calculating.
Yes, लेकिन भाव to go to the largest item set
It is time
also.
consuming.
Yeah, we have to go step by step.
Uh,
Like I have gone, okay, for example, here we found, okay, for example, I'll erase this.
we'll have to calculate over 40 triads.
Yeah. So, for example, SN, we can exclude SN and SN, but we have to go, for example, SN2, SN2 and E1. We have to check for SN2 E3. We have to check SN2 Q1. So all this, okay, see, it is only for SN2 and it is only for cardinality this. So from there, for example, we will find only these many are having more than 0.3. Okay, then again we will check for that. So finally we will get the largest set. So this question, in my opinion, if they would have written cardinality is equal to 1, then we can straight away find. However, in the question number 4, they have asked okay, this kind of question. How many association rules have minimum support of 0.4? So we will go to question 4 first, okay, before doing this. So with the same concept, what will happen? We will select only the 4 part. So 3 also will discard. So Suraj, how many with 4?
7.
Okay.
Totally 7.
Yeah, total is 7. So how do we do that now? So what we'll do
4
is
divide 10.
Yes, yes, you're right. Okay. So what? And we will write all the names, and
Okay.
we will make a matrix.
Yeah.
So we will make a matrix like this. Which all are there? SN2 is there.
SN2 is
E
3.
E1 E2 SN3. Sorry.
Yeah. SN3, E1,
Then
E2, OR,
Q3 Q
QR3,
QR3
PP3,
P3. You can write
C2,
C2 and
M1.
M1.
Yeah.
And now from here, now we write here the same E1, E2, Q3, R3, C2, M1. SN3, SN3 blank, E1, E1 blank, or to this blank. Now we start finding the this again, SN3 and E1. So SN3 and E1, see how many times they both are 1, 1. 1, 2, 3. Sorry, I was checking with this. E1, 1, only once. So straight away, it is not then 0.4, so I can cut it. Could you understand
Like
how
how
I,
are you comparing SN3, E1 means like only once you are saying
both should be 1, 1.
both should be 1, 1 in the
Yeah.
same row. Okay.
Yeah. So how many times okay, both are 1, 1. So see here, this is 1, this is 1.
Yeah.
Okay, then I come here, here it is not there, here it is not there, here it is not there. So I got only one. So one
Okay.
support
Yeah.
is less than
Once.
0.4 and we are checking for 0.4. So we'll
Got
consider
it.
anything which is more than 0.4.
Oh,
Okay.
okay. Okay. Got it. Got it.
Okay.
Understood. Yeah.
Now we go from SN3 and E2. SN3 and E2 C 1. So we had to only this one. So here we
Mm-hmm.
check, here we check, here we
Have
have got
3.
1, 1, 2, 3. So this is
Yeah.
also less than
Out.
0.4
Yeah.
out. SN3 Q3 check. SN3 Q3 1, 1. Yes. 1, 1, 1, 1,
4.
1,
Yeah.
1. 4. Okay. So this I have got. Okay. So
Yes.
this
Yes.
so this exercise when you will do,
Hmm.
so it is a symmetrical. You have to do only one part. So SN3 and R3 also we can check. R3 1, 1. Oh, sorry. 1, 2. E2 we have calculated. Q3 we have done. R3 was, this is P3, sorry, price 3, price. So 1, 1 it is there, 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 1, 1 it is there. In fact, it has got 5. So we strike this here. Okay. So here now, when you will do this, so you will get some numbers. Okay. So here we had got 7. 7 were the ones okay, who were more than 4, 5, 5, 4, and 4, 6, and 7. And here you will get some numbers. Now here, these values where it is correct, keep on writing here. For example, it is 0.4, 0.5, zero point 0.4, somewhere you will get 0.4. Now, these now 3 item sets which are there, now you have to compare them again in the set of item set 3. SN1, SN2, SN3. So for example, here I had done this exercise. So I found only this one. These are the ones which I got. SN3, QR3, PP3, this, 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 1, 2, 3, 4, and 4 only because it is symmetrical. Now when you have got these 4 items, now make the combination of these 4 items and find the support. So here I could find out only one which was having support of this 0.4, which was SN3 PP3 to QR3. So total number becomes 12. So this is how you have to solve this. This will take time, but if you follow this concept, your entire thing will be clear. You will not make any mistake.
Yeah. Got it. Yeah.
Okay. And in Britain, there is a question that is very easy. That question was,
Uh, a small doubt in this. Yeah.
yeah,
Freeze in the screen. So
Yeah.
if they have asked the first question, like number of elements equal to 2,
Yes. So straight
or
away,
huh,
you calculate K first, okay? Okay. You calculate K.
okay.
K is equal to number of attributes into number of ranks order.
Hmm.
So you have found, for example, 18. They have asked at 2, so you do 18C2.
18C2. Okay.
Yeah. Okay.
That's fine. Okay. Got it.
Okay. Next, this is a simple one. For example, that what is the probability of observing price premium is equal to 3 and quality reputation is equal to 3? This is straight away very easy. So, see price premium 3, quality reputation 3. So just see where is it is 3 3. Price premium is here 3 and quality reputation is here 3. So how many times it is becoming? 3 3 both. 3 3 3 3 3 3 and 3 3. So 4 by 10. Answer is straight away 0.4. Clear?
Just comparing ones, right? Same.
Yeah, yeah, yeah. So how many times they both are 3?
Okay.
They have
Got it.
given no 3 3.
Yeah.
They can ask okay, when it is 1 and when it is 2. So then compare 1 and 2 when it is there. How many number of
Mhm.
times?
Got it.
Okay.
Got it. Yes. Yes.
So these two are main questions from the calculation point of view, and both we have covered. Okay. Anyone, any doubt? Okay. Before we take a break of 5 minutes and then we go to ME. Hi Vinith, any doubt, any question?
No, sir.
Okay. So what I will do, I'll take 5 minutes of break and I'll relog so that we can open a new Jamboard for the managerial economics.
I'm using mobile.
Okay, okay, okay. So at least okay, we'll be able to have both okay 7 to 9 DL
Yeah,
session.
DL session we have. Yeah.
But DL session they have not informed me. Is there like a DL session today?
Yes, sir. It's been posted on Discourse and in the calendar.
But they told me that okay, they'll. Okay, okay. I will be taking this again for DL also. Maybe tomorrow, day after tomorrow, and I will request everyone who is having DL. I am the TA for that. So please, any query which is there, please post on the WhatsApp also anywhere. So before quiz one, okay, we all our concepts are clear okay, about DL.
Official DL session.
Ah,
I mean DL as in regular DL or DLCV?
regular.
Oh, it's a regular. Okay.
Yeah. So can I log off for 5 minutes? We take a break and then we assemble only the ME. All of us okay, who are having ME.
Excuse me,
For
like one more thing,
Yeah.
like the last question that we were solving right now.
Yes. Yes.
Actually, I have not joined any live session before, so that question is from week 4, right?
Yes. Yes. It
Uh,
is from week 4.
okay, so where I can get these questions?
Okay, I have solved the question which was available in the quiz. Okay.
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 Uh,
Otherwise, okay,
uh,
you can find any online source, and I'll just cover some basic concept of this. For example,
mm-hmm,
if we have got some items A, B, C, D, E, F.
mm-hmm,
Okay. So what do we do? We keep on finding the association between them, and we keep on discarding the elements which have got the support less than prescribed. For example, we say zero point 0.4. So
okay.
first we find for A, B, C, D, E, F. And for example, we find for this zero point 0.3, zero point 0.3, zero point 0.4, zero point 0.4, 0.3, zero point
Mm-hmm,
0.4. So straight away we cut okay, A, B, and E. Now we have
okay.
got only C, D, and F. Now
Hmm.
in C, D, F, how many combinations we can have? We can have C, D to F.
Hmm.
We can have C, F to D.
Hmm.
We can have D, F to C.
See. Hmm.
Okay, these are the only combinations.
Hmm.
Okay,
Mm-hmm.
now you find the support of these. Okay, for example, here you have found like a 0.4 and you got 0.3, 0.3. So this is your association rule which you find. You discard this. So as you keep on going,
Hmm.
the numbers will be more in this for association rules. So you follow the pyramidical. At every layer, you keep on striking.
Okay. Okay.
Okay.
Wait. How did we get 0.3? Say for CF to.
I'm just giving an example.
Assuming it's
Huh.
0.3, we'll reject it.
Okay, how it is 0.3? Because the data will be there.
Hmm.
Okay, these elements are there A, B, C, D, E, F, and all that. So
Hmm.
here I find that A, for example, has occurred only 3 times. Rest all times it is 0.
Hmm.
So its support is 0.3. I want,
Okay. The one you were doing last time as well.
yeah,
So, yeah.
okay, and we want to find
Okay.
out of more than 0.4.
More than 0.4, yeah.
So this straight away I cut it, B I cut it, C I cut it. Here I find it is 0.4. So I take the D, I take some, and now I go to the next layer now. Now next layer I make combinations. I check their support. So here I will select only this. So the theory basically is behind this is that if any element support is, for example, less than zero point 0.4, in future also it will not contribute anything more than 0.4. That is the theory.
Okay.
Okay.
So there's no
Okay.
point continuing with it. We can eliminate it.
Yes.
That's why,
Yeah. And finally, then we get the final sets.
Hmm.
So those are the association rules which we say. Okay. So can we take 5 minutes break and then only
Huh.
the managerial economics we join?
Okay. After
Yeah.
5 minutes, we are joining for
Yes,
Amy.
yes, yes,
Okay.
yes. And
Okay. Okay.
and Amy also will cover only the main concepts and will solve some questions.
Okay. Okay. Sure.
Okay.
For me, please could you do the recording alone?
Yes, definitely.
Same recording, right? This one.
Yeah. I'm stopping the recording so that it gets.